Hello guys, we'll be solving the problem IP address. So in this question, we are given a string S of digits and a task is to return all the possible valid IP address combinations. So an IP address can only be valid if it consists of four segments. And each segment should be separated by a dot and the value of the segment should range between 0 and 255 and it cannot have any leading zeros such as that 0 is valid but 01 is invalid. So there are numerous conditions given in this. So let me summarize all of them. So this is the summary of all the conditions. So firstly, the string length can only range between 4 and 12. So as we know, we have to separate the string into four segments and which can have a value between 0 and 255, which means that the segment length can only range from 1 to 3. So the minimum length should be 4 as it can only the segment will contain one digit. And as for the 12, the maximum length of the segment can be 3, so 3 into 4 becomes 12. An IP address can only have four segments, and each segment length should be between 1 and 3 because the maximum value can only be 0 and 255. There should be no leading zeros, and we'll be using backtracking to explore all the cases. So for the input format, the first line consists of integer t, which is the number of the test cases. For each test case, a string S containing only digits is given. For the output format, for each test case, we have to return space-separated strings, and each string should be a unique possible valid IP address. For the sample input, 2 is the number of the test cases and 2 inputs are given. So let me explain you the test. So for the test case 1, this string is given. Now we know that we have to split it into four segments and the length of the segment can be between 1 and 3. So we'll place a dot after one digit, we'll place a dot after two digits, and place a dot after three digits. And we'll check if they lie between 0 and 255. So for the first and the second, they don't return any valid IP addresses, so we'll move on to the third. So 255 is in the range, so we'll move on to the next step. So we'll again do the similar thing of placing a dot after one digit, two digit, and three digit, and we'll check if it lies between 0 and 255. So as for the first and the second, they don't return any valid IP address, so we'll moving on to third. Since 255 and 255 are in the valid range, so we'll move forward to the third step and again do the same of placing dots after one digit, two digit, and three digit. And as for the third, we can see that 1135 is out is more than 255. So we'll discard it and the values in the second and the third will be taken and we have to output it as space separated strings. Test case 2, we are given the input 0000 and the only valid way is to split it into four segments. So each segment will only contain one digit which is 0 and since there are no leading zeros, it is valid. Now let's take a look at the code. The code will be in Java and as for the approach 1, we'll be using backtracking. So here I have imported all the Java utilities. Then we have a class named solution. Then as for the main methods, I have a scanner object which will help us in taking the inputs. Then for each test case, we'll be having a string S which will be the string read by the scanner. Then we have a list of string name valid IPs which will store the result of the restore IP addresses function. So for the restore IP addresses function, a string S is given as input and a list of string is returned. So we have a list of string name result declared here. Then as discussed earlier, the length of the string should be between 4 and 12. So if the length of the string is less than 4, or if it is greater than 12, we need to return the result as there is no way to make a possible valid IP address. Then we will call the function backtrack, which will contain four inputs. Here, a string S is passed as an input. Then int start, which is the index where we are present in the string S. So initially it will be 0. Then we have a list of string named path and a list of string named result. Then since we have to divide it into four segments and each segment can contain length between 1 and 3. So we'll be using a for loop which will run from 1 to 3, and then we'll check if the length of the segment is greater than the length of the string, which means it is not possible. So here start plus length is greater than the length of the string, then we'll break the loop. Then we have a string segment which will be extracted from the string, which will start from start and have a length of length. Now we will check if the segment is valid. So as for the valid, it will take in an input string s and will return a Boolean value. So a string can only be valid if there are no leading zeros. So here, if the segment dot length is greater than 0, and if the first character, that is the char at 0, is 0, then it means that there is a leading zero. So we have to return false. Now we'll check that the number is greater than equal to 0, and if the number is less than equal to 255. And if it is true, then it will return true, otherwise it will return false. So after checking if the string segment is valid, we will add it to the path list, and then we'll call the function backtrack again. Here we'll pass the string s, then we'll change the index from by len. So we'll do start plus len, then we'll pass this list path and result. Now, if if the recursive call completes, then we will remove the most recently added elements from the path list, which will help us explore more alternative possibilities. So, since we are using recursion, we'll need to have a base case. So, we know that this uh, number of segments should be 4. So, if path dot size becomes 4, then we have to check that the entire length of the string is covered. So if the start, which is the index which we are at in the string s, is equals to the length of the string s, then we'll add it into the result. Here string dot join dot comma path represents that we'll have all the strings in the path list separated by a dot, and we will convert it into a string and then add it to the result list. Then we'll return it. So in the main method, we'll be printing out all of these in the form of space separated strings. So we'll check if the valid IPs is empty, then we'll return an empty string. Otherwise, all of these strings in the valid IPs will be separated by a space, converted into a string, and then be printed. Then we'll close this channel. So for the approach one, we saw that we used backtracking and VFS. And here for the approach two, there is another way, that is iterative approach. So how it works? We'll be using three nested loops to place three dots in different positions. And there will be four substrings, and we will check if each of it is valid. And we will store the result if all the four segments are valid. So as for the code, we can see that if n is less than 4 or it is greater than 12, we'll return. And we'll be using three for nested for loops. And we'll be checking if all of the substrings are in the valid range. And if it is valid, we'll add it to the result and we'll return the result. A segment can only be valid if it does not contain any leading zeros and if it is between 0 and 255. So there are another ways to solve the problem, such as dynamic programming and bitwise manipulation can also be used, but these ways are not so efficient, so they should not be mainly used.